Perfect. I'll just intro you for the YouTube recording, and you
Right.
can take it from there. So this morning we are kicking off with Eric, who is going to be speaking about cross-database queries in Azure SQL, which I thought was not a thing, but I'm curious to see how this works out. So it's all yours, Eric.
All right. Thank you, Daniel. First of all, thank you for having me, and I'm very excited to be here for the first time. So I'm going to share my screen and start the discussion. All right. So first of all, we might be wondering, as you said, why we even need to talk about some cross-database queries in Azure SQL. First of all, what are cross-database queries? Cross-database queries are the simple fact of transferring some data from one database to another database. So this task is actually very simple when we are transferring data from two databases when both databases are actually lying inside an instance of SQL Server on-premise. But actually two databases lying in an on-prem SQL Server instance and two Azure SQL databases might be serving the same purpose, but they are behaving differently. And that's because Microsoft SQL Server and Microsoft Azure SQL databases are not the same product. They serve the same purpose again, but they are behaving differently. So let me show you what I mean and how this works. First of all, I am going to demonstrate two use cases for this demonstration. Let me just open my demo. Here it is. So I am going to demonstrate two use cases. The first use case is going to be a very simple one, apparently a very simple one, and it will show how to transfer some simple data between one Azure SQL database to another Azure SQL database. And we are going to see why this simple use case needs a workaround. And the second use case we are going to talk about will involve the use of a very unwell-known stored procedure called SPExecuteRemote. And with the help of this stored procedure, we are going to build a one-action transfer, archive, and delete process, which might be a kind of lifesaver. It might be very useful whenever you will be working on Azure SQL. So first things first, let me show you what I needed for the purpose of this demo. First of all, I have created a subscription in the Azure portal. If you are not familiar with it, let me show you very briefly how it looks. Here we are in the Azure portal. And you can see that I have created the subscription, and I have called this subscription Eric. And if I click on this subscription, you may see just a second. Okay, let me search for the resource group. That's it. I have created a resource group, which actually is a kind of folder gathering any resources I would need. And I have called this resource group demos. And in this resource group called demos, I have created three objects. I have created one SQL Server, which you can see here with this cylinder icon and with the with this little icon next to it. And I have also created 2 Azure SQL databases. One of them is called production database. It will actually serve as a production database for this demo, and another one called archive database. So let me go back to SQL Server Management Studio, where I have connected to this SQL Server, which is called cross-DB demo server. And you can already see the 2 databases that I have created. I just want to let you into a little tip. Whenever you need to create a database from an Azure SQL Server, you might be tempted to just right-click the databases and go for a new database and go on with this process. I warmly recommend not to do this unless you know the exact script to define all the settings that you need. But otherwise, creating a database using this right-click option would automatically charge you for a very heavy pricing tier that you might probably not need. So I recommend to create a new database using the Azure portal. You can just go search for databases. For example, you can search for databases. And just create a new one. And this is much more recommended. You can avoid spending a lot of money using this. So with no further transition, let's jump into the first use case I want to demonstrate, which is transferring some data between our production database into our archive database. So let me expand those databases. Right now, I don't have any tables in any of them. So the first thing we're going to do is create a simple table in our production database. Then I am going to select the production database here. You might notice that I'm doing this using the GUI and I cannot in Azure SQL Server use as a use command. It does not work. It is not supported in this version of SQL Server. So let's create a very simple table called prod table. It will include some columns like an ID, name, last name, and a few details. We can imagine that we are managing the database of a small company. And this could be our employees table, for example. So let's create this table. All right, we can see that our table has been created. And we will also insert some records into this table, actually 4 records as following. Great, and we can have a simple select statement to check that the records have been inserted. And they have. All right, so now let's suppose that we wish to transfer a record from the production database, from this table, into another table, a similar table actually, into the archive database. So the first thing we would do in that case is to create an identical table in the archive database. And that's what we are going to do right now. That's it. And let me select from this table. All right, so we have our table created, but it does not has any row in it because we did not insert anything into it right now. Okay, so now we want to insert actually a row. We want to insert a row, for example, row with ID number 4. Actually, let's suppose that Mr. Fernando Cobo no longer works at the company, and we wish to transfer this record with ID number 4 into the archive table we have created. So our intuition would be to use this command and insert into select command. With a filter where ID equals 4. So let's run this query. And as you can see, we are getting an error. The error says that the reference database and or server name is not supported in this version of SQL Server. And this error is actually the reason why we are speaking about this today. The reason why we got this error is because we are not having here an instance of SQL Server. We are having two Azure SQL databases which are communicating with the use of this SQL Server. But this SQL Server is not an instance of SQL Server. It is a logical server that is needed so that our databases, our Azure SQL databases, have a place to connect to. I know it is a little confusing concept, but it is very important to understand that this is not an instance of SQL Server, and therefore our two databases cannot see each other. They cannot communicate with each other, and this is the reason why we are going to need a workaround process here. So, in order to successfully transfer some data between our production DB into our archive DB, we are going to need to create 4 objects in our target database, which is actually the archive database, the one we want to transfer data into. And these 4 objects are a master key. The first of all is of them is a master key we need to create in the archive database. The second object is going to be a database scoped credential. And actually, the master key is being created in order to protect the database scoped credential. The database scoped credential is this very object that will allow a communication between the two databases. It is a kind of middleman. After we will have created the database scoped credential, we will need to create an external data source. Then the external data source will actually define where we want to bring some data from. And this external data source, you can already guess, is going to be our production database. And after the external data source will be created, we will need to create an external table that will lie inside our archive database, and it will serve as a kind of mirror of any table we want to define lying in our source database. Actually, our external table is going to mirror our prod table lying right now in the production database. Let me show you, let us do this together, and let me show you how it works. So we are in the archive database, as you can see, and we are going to create the master key. The syntax for creating the master key is pretty straightforward. I choose the encryption method by password and give it a strong password. Of course, if you do this in production environment, get a stronger password than this one, of course. This is just for demo purpose. So I have created this master key. I suggest to check that it has been actually created by running a select from the DMV sys.symmetric keys. Let's do that. Yes, and we can see our master key has been created. All right, now is the time for creating the database scoped credential. And please pay attention to the syntax, because this syntax has the with clause, and it requires details for what is called identity and secret. The identity is the login name we used to log in into the server. Actually, we are talking about this login, and the secret is going to be the password. All right, so identity is, of course, Eric Rouach, which is my name, -crossdb, and the secret is this password, which also obviously should be a strong password. So get a stronger one than this one whenever using the creation of a database scope credential. So let's create this object. And the command has completed. So now we have a master key and a database scope credential. Still in the archive database, we can create now our external data source. Please pay attention to the syntax, which also has a with clause, and this with clause has four parameters it requires. The first of which is the type, which has to be RDBMS, which stands for Relational Database Management System. The location is the name of the server, the name of this server actually. You can grab it from the Azure portal or just copy paste from here. Both are okay. The database name, now with the database name, it is time to specify from which database you wish to bring data from. And in our case, it is a production DB, this name. And the credential clause specifies the name of the database scope credential we have just created. So this should be matching with the name of the database scope credential you have created before. Let's run the creation of the external data source. All right, we can see that this has been created successfully, and we can actually have a look at it. If we expand the external resources folder, we can actually see the external data source called production database. All right. Now we have created this external data source. We can now create an external table. Why do I want to create an external table? Because I want to create some table that will reflect what is happening in this table in my production database, so that I can be able to transfer data from the external table into the real table I want, which is actually, let me refresh. All right, my real target table is this archive table. But right now I cannot transfer from here to here. I need this external table so that I will be able to have two tables lying in the same database. Because right now this table is in another database and I cannot just run an insert into select statement to populate my archive table. So, but now I have prepared and set up my external data source, I can create the external table. So I'm going to create it. I'm giving it a name similar to the real source table, and I'm adding the _ext to specify it is external. And as you can see, it has the exact same columns, but pay attention to the syntax. The creation of an external table also has a with clause. It has to specify the data source, which is the production database. The data source is actually the name of the external data source, this one. And we have to specify the schema name and object name, actually the table. So if we want to create an external table reflecting this table, the schema name has to be DBO and the object name has to be prod table. So let's create this external table. All right, it has completed successfully. Let's also have a look at it. you can see that we can expand the external tables folder. And we can see that our external table has been created. Let's also expand the columns so that you can see that it has the exact same columns as the real archive table, or actually as this table, because we created according to this table. And our column names are matching. So it is important to say that this external table does not hold any data at any time. It will only show you what data is lying in the source table at the moment of the at running time only, but this table does not hold any data. So let's select from the external table, and it will show us what is actually lying right now in the prod table. And we can see our 4 records. All right, so now that we can access the data lying in the production database, thanks to this external table, we can very easily transfer from the external table into the real archive table. Actually, from the external into the archive. And for this, we are going to run a very simple query. I'm going to insert into archive table from the external table where ID equals number 4. One row has been affected, and let's check now the contents of the archive table to see if the record has well been transferred here, and it has. So Mr. Fernando Cobo is now in the archive. All right, I might want to delete this record from the archive table right now, but I will keep it there for the upcoming. So now that we have successfully transferred data from one Azure SQL database to another Azure SQL database, we might want to go one step further and try to build a process which will allow us to do a few things. We will want to transfer the database, the record from the production database into the archive table, and also delete it from the production database after it has been transferred. And we would like to do all this with the press of one button, or with the execution of one single stored procedure. Are there any questions before I go on with the second use case?
No, I think it's pretty crystal clear. So there are no questions at this time.
All right.
There's one question actually. Hi, is this a better technique than using SPAdd linked server?
SPAdd linked server. What do you SPAdd linked server? SPAdd linked server. Actually, I'm not familiar with the use of SPAdd linked server.
So linked servers is for on-prem. I don't think you can use linked servers.
I doubt it can work on inside an Azure SQL Server. But
I think what you're describing is basically like a linked server, but for Azure SQL.
Yes, definitely. It is exactly the same concept than a linked server, but the linked server cannot work in this version of SQL Server, of course. So I hope this answers the question. Actually, I have not tried this, but I really doubt it would work. And I see there is another question, if we can do this in a transaction. Yes, of course we do. Definitely.
Awesome. Those are the questions. I was
Great.
wondering a little about the transaction myself, actually, so I'm curious to see.
All right. So actually, the second use case is really interesting and a little more complex, but let's go into it. So we are going to meet a very interesting source procedure, which was kind of a lifesaver for me. It is called the SPExecuteRemote, and as its name says, it will allow us to execute a procedure lying in one database from another database. And let me show you how this works. So we are still going to need the previously created objects, actually the master key, the database scoped credential, and an external data source. But we won't be using the external table itself. Actually, we are SPExecuteRemote is going to allow us to avoid the use of an external table. So let's see how this works. The first thing we are going to do is creating two simple stored procedures inside the production DB. We are going to create one stored procedure for selecting the table and one other very simple stored procedure for deleting a record from this table, from the prod table. So first of all, I want to move to the production database. All right, so I'm just running a simple select to see that our 4 records are still there, and they are. So as I said, I'm creating a very simple procedure that I'm calling USB select from prod table. So it's doing a very simple select, and I'm using a parameter called ID, so that I can provide any record I want when running the stored procedure. So I'm creating this procedure, and I'm going to create another stored procedure, which is deleting any record you like, also using a parameter from the prod table. Okay, so our 2 stored procedures have been created. Let's check that they are actually there. And they are. Great. So what we are going to do is actually we are willing to execute these 2 stored procedures, but from the archive database. And actually, that's the reason why we still need our master key and we still need our database scope credential, because we still need this communication to be established between the 2 databases. I would like to break down the process very little bit before I get to the final script and to the final stored procedure, so that I can demonstrate a problematic issue and how to solve it. So now I want to go back to the archive database, and there I want to start building a stored procedure which will actually get a record from the production database, insert it into my target table, which is the archive table, this one. And afterwards, I also want to delete the record that has been inserted from the production database. All right, so I want to do that in one stored procedure that I will be running from the archive database. So let's start building this stored procedure. Sorry. All right. at this point, the procedure is going to be doing two things. The first thing is going to be creating a temp table with the exact same columns as the archive table columns. As you can see, ID, name, last name, cell, email, and user ID. All right. And then I'm going to run SPExecuteRemote. I'm going to execute SPExecuteRemote so that I can insert its output into my temp table. Please pay attention to the syntax of executing SPExecuteRemote. It's a little tricky and not so friendly, I must say. So let me explain it. First of all, it has two mandatory parameters, which are data source name and the statement, which is shortened to stmt. And you will see that I have added two parameters, and that's because I'm using parameters in these two simple stored procedures that I have created before in the production database for the ID. So in case we do use parameters, we will need to add those as well. But first things first, the data source name is actually the name of the external data source, the production database. If you don't remember, you can have a look at here, the external data source, and take the name from here. The statement is actually the name of the stored procedure I want to run. But you might be wondering if it has to be a stored procedure or not. And the answer is no. It can be also any ad hoc query you would like to run. So you would just need to insert the code. But in case it is a stored procedure, so you need to specify the name of the stored procedure. And in case it's using parameter or parameters, the name of these parameters should be specified right here. And in addition to that, you also need to specify it here in the params parameter, specifying the name of the parameter and its data type, which is an integer in our case. And last but not least, you also need to give a value to this parameter. I might have done this differently and maybe using a parameter here, but for the sake of this demo, I decided to do it this way. All right, so actually, we are going to create a stored procedure in the archive database. But I see that I am in the production database, so I'm going to switch to the archive database before I do so. Great. So I'm going to create a stored procedure. Great. Let's have a little look to see if it has been created. And it has. Great. Now, before I execute this stored procedure, let's remember what it is supposed to do. So when executing the stored procedure, we will expect a few things to happen. We will expect a temp table to be created with these columns. And we will expect this temp table to be populated with the output of this stored procedure, which is actually doing a simple select on the prod table where ID number is 4. So we will expect one record with ID number 4, the record of Mr. Fernando Cobo, to be inserted into our temp table. At this point, that's all I want to demonstrate before I go further. So let's execute the stored procedure. And as you can see, we are getting a quite awkward error. We can see that it is actually a very familiar error. I'm sure every one of you has encountered it. Column name or number of supplied values does not match table definition. Usually when getting such an error, the first thing we would do would be double checking if the if the names of the columns are matching. We actually wanted to insert from the production table. So let's check the columns, and we have ID, name, last name, cell, email, and user ID. ID, name, last name, cell, email, and user ID. We can see that the column names are perfectly matching. Also the data types and everything. It looks perfect. So why are we getting this error? The reason we are getting this error is because the execution of SPExecuteRemote, when it executes a select statement, whether it is being done by a source procedure or an ad hoc query, the execution of a select statement will automatically display an auto-created additional column, and this column is called shard name. Here it is. And this column has a varchar 128 data type. It is very important not to miss this in the Microsoft documentation whenever you read about SPExecuteRemote. So if you read it too quickly, you might miss that point and spending a lot of time solving this issue. So let me show you how to take care of this issue. Of course, we need to take this column when creating the temp table we want to insert the data into. So I'm gonna do again what I just did in the previous step, but this time when creating the temp table, as you can see, I'm adding the shard name column with its data type. So now, when executing SPExecuteRemote, that automatically adds this column, will have a target column to go into. So let's recreate the stored procedure. As you can see, this time I have added a simple select from the temp table inside the stored procedure, so that when we execute it again, we might see immediately if the record has been inserted. And we might also see what this shard name column displays. So let's alter the procedure actually. Great. Now we can execute it. That's it. Have a look. So we have our record with ID number 4. And as you can see, the shard name column is actually displaying some metadata. It is quite unclear why it had to be added to the output of SPExecuteRemote when executing a select statement, but I believe the Microsoft developers needed this output to go somewhere.
So London DBA asks, is shard name always the last column returned in the output from SPExecuteRemote?
Yes, it is. Definitely. Yes, it is. It will always come last. Yes. Okay. So now I hope this has been made clearer. It is time to rewrite the whole stored procedure so that we can have the whole process. So let's go through the steps of the whole process. So we are going to alter our already existing stored procedure in the archive database. This one, yes. So again, we are creating the temp table. We are checking if it doesn't exist, and if it does, we are creating it with the shard name column. Then we will insert into it the output of SPExecuteRemote when executing the select part of it using the ID parameter with value number 4. Once our temp table is populated with this record we want to archive, we're going to use a merge statement. We are going to merge this record into the archive table, the real target table, using the temp table, which will feature only one record, actually. This is the on-close our merge statement. And what this merge statement is going to do is simply, it will check if our ID number 4 already exists in the archive table. And in case it doesn't, if it is not matched by the target, it will insert it into it. Of course, at this time of the merge statement, I do not need to specify the shard name column because I do not need it, and it also doesn't exist in the archive table. All right. Then I'm using kind of control simple print statement, because it's nice to have on the display of your result. At this time, it's okay with me to drop the temp table. I don't need it anymore. And then I will be using SPExecuteRemote again, but this time it will be executing actually the delete, the second stored procedure we have created in the production database, the delete from prod table. And it will also use a parameter. I will be willing to delete this same records having ID number 4. All right, so it's time to recreate this stored procedure with all its steps. That's it. And now we can execute it. So when executing it, it will be, let's go again before I execute it. It will create a temp table, populate it with one record, check if this record exists in the archive table. In case it doesn't, it will insert it. Then it will drop the temp table, and then it will delete a row with ID number 4 from the prod table in the production database. All right, so let's execute the stored procedure. All right, so it has executed successfully, and we can see that no rows were merged to the archive table. And that's okay, because if you remember at the end of the first use case demonstration, where we already had a record in the archive table, we already had this archive with ID number 4, and I decided not to delete it. So it means these 0 rows were merged to archive table, just means that our merge statement worked properly. So it is actually what I expected to see. And now is a good time to check our tables and see if the data is actually there or not there. So let's first check the archive table and see if our record is still there, and it is. Fantastic. And more important, let's check if the record has been deleted from the production database. So let us switch to the production database. All right, and run this simple select statement. And as you can see, record number 4 of Mr. Fernando Cobo is no longer there. So our deletion using the SPExecuteRemote stored procedure has also worked properly. And now is the time to thank you all for watching.
Cool. And so we touched on transactional integrity. If you do this stuff using linked servers or what have you, it'll introduce all kinds of complexities with, if you use begin transaction and commit transaction. And if memory serves, you need to set up a whole host of things. Is that sort of set up? up in Azure SQL, or do you have to jump through all the hoops there too?
You actually have to set up in all the objects. What actually do you mean?
So if you're using a cross server transaction in an on-prem environment, you
Yes.
need to set up like a distributed transaction coordinator or something on those lines to sort of keep that two-phase commit thing in sync, so that it's possible to use it.
Okay.
And so if you change your procedure to begin transaction, and then you do the transfer and the delete, and then you commit the transaction, does it work that way? Is that something you can do?
Yes, you may definitely wrap the whole thing into a transaction.
Wow.
Yes.
Then that's actually one awesome feature that you can't do with just a standard setup of linked servers. So that's actually a really cool thing.
Yes.
Awesome. I don't think we have any other questions. I'm actually, there is actually a question. London DBA says, because SPExecuteRemote returns shard name, this means you always have to insert into a temp table first. That's a real drag. Pity no option to exclude shard name. That way you'd be able to insert into target table without having to go through the temp table. Would be easy to add option to exclude shard name.
Yes,
if Microsoft chose to. Yeah.
Yes, I'm afraid there is no workaround the shard name column right now. I really hope Microsoft finds a solution for this. Actually, there are quite many issues around this this thing. There are other possibilities, like instead of using Azure SQL databases, one might prefer to use a managed instance, which does support cross-database queries without the use of creating the external objects. But of course, it depends of other parameters and whatever your client decides to work with.
Yeah, of course.
It's also a matter of cost, of course.
That little aspect. Yes. There is a quite significant cost difference. Yes.
Yes.
I'm curious as to the origins of the shard name. I think you can set up. Maybe it's a different. Maybe it's a hyperscale thing, or one of those features of Azure SQL where you can have the data in multiple databases or in multiple locations, or something like that. But it kind of makes sense. So I guess. Awesome. So if there are no other questions from the audience, thank you so much for presenting on GroupBy. We have another actually 40 minutes or 30 minutes, 40 minutes before the next session. So if anyone wants Eric or me to freeform on anything, go ahead and ask in the chat. Otherwise, we'll just put up a slide and wait for the next speaker or something. Chat's eerie quiet. I think everyone's having an early morning. Cool. I did notice you have 27 degrees. I'm not envious.